All right, so in our next problem, we have a similar situation, but notice something. A person pushes a car, so we're going to treat muscles as though they are elastic energy. And since the parking brake is on, that clearly means we're dissipating energy, losing it to friction of the brakes. So we have no height and we have no speed, which means we start off completely with elastic energy. Now we wind up at the top of the hill. Notice that there's still no speed, so there's still no kinetic. So that means our energy is distributed as gravity energy and dissipated. And some of you might have made this 50-50. That's totally fine. The important point is that you don't want anything going into the kinetic or elastic bin at the end. So our equation is going to be E elastic is E gravity plus E dissipated. All right, next question. We have a set of bricks on a spring. Notice we have no height and no speed, so all our energy starts off as elastic. And notice here we have our speed bigger than 0. I'm going to assume there's no dissipated because they don't mention air resistance at all. So I'm going to distribute this as gravity and kinetic. Again, it's not important whether you make it 2 or 2 or 3 and 1 or anything like that. What's important is make sure that you don't have anything inelastic or dissipated. So we have elastic energy equals kinetic plus gravity. And then for number 6. We have a crate propelled up a hill by a light spring. Notice we do get some height. They should have made that clear. So we have all elastic energy, and that energy is becoming gravity and kinetic. Again, if you decided that, hey, you think that there is friction and you did add a little bit of dissipated energy, that's okay. So you could set up your equation as E elastic equals E kinetic plus E gravity. And if you had the optional dissipated energy, that's fine too. All right, number 7. We have a bungee jumper. And, I'm just going to write this one really quickly. So we've got all gravity because the cord is just sitting there unstretched. And then at the end here, we've got no kinetic. We've got a little bit of gravity and we've got a little bit of elastic. I'm not sure what the distribution of energy is, but I do know the equation should look like this. And then for the last one, we have an elevator moving downwards and it's brought to rest on the ground floor. So that means we have some kinetic and we have some gravity. And then all of that energy gets completely used and put in a place where we can no longer get to it because the elevator stops. So we have kinetic plus gravity equals dissipated energy. So that's it for the homework problems. I hope that was helpful. And I'm going to be posting solutions to homework number 2 that I assigned you today to help you study for the appraisal on Monday.